so in this question, I've been given my quadratic, y equals x squared plus 8x plus 12. And I've been told to write it in the expression x plus a squared plus b. Okay, now what that means is the completing the square form. And all that means is I want to write this as a perfect square. So x plus a squared is what we'd call a perfect square. And really quickly, let's give a quick example. So x plus 3 squared. If I had x here plus 3, 1, 2, 3, and I squared it, so x plus 3, 1, 2, 3, what would I get? So x times x would give me x squared. 3 times x would give me 3 lots of x, and here the same, 3 lots of x, and then over here I would get 3 times 3, which is 9. So if I expanded that, I would get x squared plus 6x plus 9. Now, if this isn't seeming familiar, then go back and have a go at expanding brackets and practicing a perfect square. But hopefully you know that when you're expanding double brackets, you can draw it as a square, and that's why we call it completing a square. So a perfect square is something that forms a perfect square like this. Okay, so when you expand the brackets, they give you can represent it visually as a square. Now, sometimes you can't do that. So what we do is we take the first part of the quadratic and we write it as a perfect square. Now, if you're ever trying to figure out how you could do that, the key is that you're always halving the middle coefficient. So if I tried to represent this visually, so x squared would just be a square, x times x would give me x squared, and then I need to add on 8x. So what I could do is just split that in half. That would give me 4 lots of x, so x plus 4, and this would be, each of these would be a length of x, because if that's a side length of 1, 1, 1, 1 times by x gives me x, so that's why this bit would become 4x, and over here we've also got 4. So x plus 4, x plus 4. So if I had x plus 4 squared, that would be a perfect square, okay? But if it was a perfect square, then what would the missing bit be to complete the square so that it's a full square? This part here would be 4 times 4, which is 16. Now, obviously that's not the same as the quadratic that I want to deal with. So when I complete the square, I think, okay, if I write this part as a perfect square, which you do by halving that coefficient and putting it in brackets, what do you need to do in order to get it back to its original form? So x plus 4 squared gives you, that would be x plus 4 squared gives you x squared plus 8x plus 16. Okay, so this here is x squared plus 8x plus 16. Now, how do you get from here back to x squared plus 8x plus 12? Well, hopefully you realise that this part and this part are exactly the same. That's why we do the completing the square. And then how do you get from 16 to 12? What's the difference? Well, 16, if I took away these 4, I would get x squared plus 8x plus 12. Okay, so this expression, the whole square, x squared plus 8x plus 16, take 4 gives me 12. And I know that x plus 4 squared can be expressed as this. So my answer would be x squared, I'm trying to find some space, x plus 4 squared, that gives me this, so I could write it underneath, x squared plus 8x plus 16. You're trying to get to the original, so this, take away 4, gets you back to your original. I ran out of space, so the next example we'll try and do a little bit better. Okay, so here's the second example, and sometimes the reason we use completing the square is because if we try and factorise it normally, we just wouldn't be able to. So the factors of 3 are simply 3 and 1. There's no way we can combine them to make 10x. Okay, so remember, when it's given in this form, that is the completed square form. And what you try and do is write the first part of your quadratic as a perfect square. So let's think, to write this as a perfect square, x times by x is x squared. And then remember, you halve the coefficient so that you can draw it as a perfect square. So that would be plus 5. And I'd plus 5 over here too. 1, 2, 3, 4, 5. Okay, so if this was a perfect square, the first step is I have identified that this is a perfect square, x plus 5 squared. What would that be? Well, if that was 5 as well, 5 times 5 gives me 25. Okay, so as a perfect square, x plus 5 squared is x squared plus 10x plus 25. I just did those two quickly, 10x. So if x plus 5 squared, that's the perfect square, can be expressed as this, and I want to be expressing this quadratic, what would I do to get back to there? Well, I know x plus 5 squared is this, so the first part of my equation is x plus 5 squared, but I also know that it's plus 25. I don't want plus 25, I want plus 3. So I'd have to chop off everything over here to get plus 3. So what have I done to my perfect square? I have taken away 22. Okay, so I could express this as x plus 5 squared, take away 22. The super quick shortcut is find half of the coefficient, so always half your coefficient of x, work out what that would be if it was a perfect square, and then subtract or add in order to get it to be your perfect square. So here we are jumping up in difficulty a little bit. So we're being asked to solve the equation using completing the square. Now, it's not always going to look great visually if we're trying to draw a perfect square when we're dealing with negatives. So let's think about what we did in order to make it a perfect square. We halved the coefficient of x. So ignore that equals 0 first. First, I'm just going to complete the square. How do I do that? By halving the coefficient and figuring out what this would be as a perfect square. So x take away 4 squared would give me x squared take 8x plus 16. Okay, so if I expanded this, the perfect square would be x squared take away 8x plus 16. Now, how do I get from plus 16 to negative 2? I have to, so for, that was embarrassing. So how do I get from 16 to negative 2? The difference is I have to subtract 18. Okay, so this in its completed square form would be x take away 4 squared take away 18. So the first step is you literally write this as a perfect square by halving the coefficient of x, and then you work out if that was expanded, what's the difference between that and your original. So now we can make it equal to 0 and we need to solve it. Now, when we're solving an equation, we are literally moving things from one side of the equation to the other so that we can get our x value on its own. So we always do the inverse. So the inverse of plus 18, negative 18 would be plus 18. So I'd be left with x take 4 squared equals 18. Then what could I do? Well, using BIDMAS, I would have to square root everything because this is all inside a bracket. So I square root both sides. So you'd be left with x take 4 equals the square root of 18. And my final part would be, oh, and also remember that every square number, so let's say 49 is a square number, that could be 7 squared, or it could be minus 7 squared. Okay, so 7 times 7 gives me 49, but negative 7 times negative 7 also gives me 49. So every number has both a positive and a negative square root. Okay, so what's the last part of the equation? I would add 4 to both sides, And so my two solutions, because every square root has a positive and a negative square root, would be positive square root of 18 plus 4, but also negative root 18 plus 4, or to make that look nicer, I could write it as 4 take root 18. And then let's work that out just so that you can see. So root 18 plus 4 would give me, my first answer would be x is 4 plus 3 root 2. My second answer would be 4 take root 18 is 4 take 3 root 2. And that's how you solve an equation using completing the square.